Radiation, it is yet another method of heat travel, heat transfer, or heat propagation. Conduction and convection methods always require a medium, whereas this method of heat travel doesn't require the medium. When the heat follows this method of travel, it is in the form of electromagnetic waves. No medium as such is required. When the electromagnetic waves travel as radiation, then the speed is equal to that of light, and like electromagnetic waves, radiation also can be absorbed, can be reflected, can be transmitted. Depending on the nature of the surface, we could calculate different quantities related with these. Mainly you could say that radiation, amount of radiation always depends on the temperature difference and the properties of the surface that is concerned or that is involved. Now we are going to study the most fascinating way of heat travel, that's known as radiation. When heat follows this method, it travels in the form of electromagnetic wave which requires no medium. When radiation energy is traveling, it has the speed of light and it is absorbed, transmitted, and reflected quite as in the case of electromagnetic waves. You see, the amount of energy radiated will always depend on the nature of the surface concerned with and also the temperature difference between the body or the source and surrounding. When the emission is taking place, foremost thing here to remember is that radiation energy will be having the effect of warming. Some person, just to confuse a simple audience or s- normal patients, they say that I am going to make the infrared treatment, but infrared treatment is nothing but just giving the heat energy someone to directly or indirectly. Infrared rays are radiation waves which have the heating effect and they travel in the form of electromagnetic waves. When a source is there and it is capable of emitting the radiation, the amount of energy emitted per unit area, per unit time, this is called emissivity or emissive power. This will be having the unit watt per meter square. For perfectly black body, it's going to be equal to 1. Absorptive power likewise will define by the energy absorbed by some surface divided by the energy totally incident on that surface. Energy absorbed divided by the total energy incident on that surface. This ratio is known as absorptive power. Obviously, it will have no unit or no dimension. Perfectly black body is going to absorb all the wavelengths incident on it. Now we'll study what is Kirchhoff's law. Kirchhoff's law says that ratio of emissive power and absorptive power for any body is going to be constant and equal to that of emissive power of perfectly black body. Or else you could say in another more simple way that emissive power for any body is directly proportional to absorptive power of that body. Emissive and absorptive power are directly proportional to each other. You see, it also says that if someone is good emitter, it's obviously going to be good absorber. Suppose you consider the sun as a perfectly black body, that means it is capable of absorbing all the colors, wavelengths incident on it. It means it is capable of emitting also. So it goes with everybody. If it is a very good emitter, it is going to be very good absorber. Good emitters are good absorber. Not only that, we could also say that if some surface is going to absorb green wavelength, it is going to emit also when it will be heated and allowed to radiate. So Kirchhoff's law has very wide application in atomic spectroscopy. What is Stephen Boltzmann law? It says that energy emitted per unit area per unit time from a black body is proportional to fourth power of absolute temperature. You could also say this is equal to sigma T4. But here in this case, E is not the energy. It is energy per unit area per unit time. If you use area, time separately, then in this relation you could say E is the energy. Whereas in the above formula, it is the energy per unit area per unit time. Sigma is known as Stephen's constant. It has the value 5.67, 10 to the power minus 8. This is watt per meter square, Kelvin 4. But remember, this relation is going to be true or applicable only for the black body. If you use real body, here we are going to have the relation. Emissivity will also be used here. For general body, means if you want to apply it for any body, you have to use this additional term. What is this? Relative emission. Epsilon here is known as relative emission. This is the ratio of emissive power of a body and that of black body. Relative emission. For perfectly black body, the relative emission is going to be 1.